Alright, this video is for after watching the vocab notes for in class 73. We're going to start with some beautiful inscribed angles. Inscribed angles are awesome because they are half their intercepted arcs, and then central angles are still the same as their arc measure. So what I'm going to start with here is I have this arc measure of 50 degrees, which means the central angle right here is also 50 degrees. And then I also notice that this arc, the distance between these 2 points have a tick between it, which means the distance between these 2 points that have the same tick are the same, which means this is also 50 degrees. Which means angle 1, being the central angle that intercepts this arc, is also 50 degrees. Now, with that, we got some math that we need to do. It's not too hard, but what I'm going to look at is I'm going to look at this angle right here. It has an inscribed angle. The point of the vertex, or the vertice of the angle, the central vertex, is on the circle. So its arc is this arc right here, which is this whole distance. And what I have is I have a diameter, which means it's a arc is a semicircle. So I have 50 and 50, which means this beautiful arc right here is 80. So with that arc there being 80, I can look at this intercepted arc of the inscribed angle, my orange marking, has 130, divide that by 2, and I get 65 degrees. So this angle here is 65 degrees. Okay, so with triangle sum theorem that this is 50 and this is 65, I'm going to take 180 minus 50 and 65, and I'm going to also get 65 degrees. Or this is a radius and this is a radius, because they come from the center of the circle, isosceles triangle, so these base angles are the same. Alright, the next one I got here is this beautiful inscribed angle. I have an inscribed angle at angle 1. Its intercepted arc is right here. This central angle is 120 degrees, so 120 degrees means this is 120 degrees. Now you can think about this arc and this inscribed angle and this arc are intercepted. So if I take 120 and I divide it by 2, I get 60 degrees. So angle 1 is 60 degrees. Now for angle 2, you can think about it two ways. Its arc is this distance right here, and if I know that this minor arc is only 120 degrees, that means this arc here is 240 degrees, or two central angles add up to be 360, so if I have 120, I'm left with 240. So once again, that came from 360 minus 120, either by arcs or by central angles, and that's how I got 240 degrees. Alright, moving on to example C. We got a little bit of things going on here. Not too bad, but let's get that refocused. So, arc here is intercepted by these 2 points. I'm going to fill this arc in here. I'm going to trace back to where the 2 angles that intercept that are. So if I come back, this line right here intercepts. So that is 35. And then I see also that I have these nice beautiful lines that angle 2 also intercepts that arc. So 2 inscribed angles that intercept the same arc are going to be congruent because they share the same arc measure. So if this angle over here is 35 degrees, that means angle 2 is also 35 degrees. Applying that information over here to this other side, I have angle 1 and I have angle 3, and I can see that they both intercept this arc right here. So that means that their angle measures are the same, but I need to figure out what angle 3 is. So what I'm going to do is I'm going to look at this information right here. I have a 90 degree. So either way I can find angle 1 or angle 3. This is 90 degrees because of this right angle here. And so with that 90 degrees, I'm going to take 180 minus 90 minus 35, or minus the sum of these two. Either way, I'm going to get the value of 180 minus 90 minus 35, so I can read what I'm talking about, and I'm going to get 55 degrees. So angle 1 and angle 3 are both 55 degrees. And once again, the reason why they are the same degree measure is because of them being inscribed and intercepting the same arc. Alright, jumping here over to D, I see that I have some parallel lines. With these beautiful parallel lines, I know I have alternate interior angles, so I'm going to find some alternate interior angles right here. There's a set. There's a set. And then I could use this one and this one, but I'm going to see which one gets me information. So, this is an inscribed angle. The vertex of it is on the circle. It intercepts this arc. So before I cut things in half from the arc, so this time I need to take 33 times 2 and get 66. That means this arc measure here is 66 degrees. So with that, this angle 1 is a central angle because its vertex is on the center of the circle. So angle 1 is worth 66 degrees. Alright. So now I'm looking at some other mathematics that I can do and find things out. Let's see here. 66. So, major arc. Let's see. Trying to think of how I can figure this out. Not a quadrilateral. Let's see here. Angle 2 intercepts nothing, but is congruent. Oh, angle 2 and this angle here are in alternate interior angles, so angle 2 is 33 degrees. My brain just, I said that, I didn't write it down. It's getting very confused. Alright, moving on to the next one. Alright, we're at E. So we got some beautiful angles going on here. First of all, this inscribed angle, which is this big angle right here. Let me change my color. That red pencil and I are just not friends. This big angle right here is inscribed and it lands on the diameter as its semicircle arc. So since it's on the diameter or it intercepts the semicircle, half of 180 degrees makes this angle here worth 90 degrees. With that being 90 degrees and this being 30 degrees, angle 1 is going to be 60 degrees because of triangle sum theorem. So since angle 1 is 60 degrees, we're going to figure out what else we can do. So with that, this is 180. So this semicircle is 180. And then angle 1 intercepts this arc right here. So that's angle 1, which is 60. So if I double 60, I get this arc measure of 120. Now the reason why I need to do that is because angle 2 is inscribed and it intercepts this arc. So if I have 180 and I have 120, I need to figure out how much I have left over. So 180 plus 120 is 300, so that means the pink angle is left with 60 degrees. Now, I didn't have to do it that way. That is a 60 degrees. I could have just taken 30 and doubled it and been done a lot quicker, or seen that these two angles intercept the same arc, so their measurements are the same, and so this is 30 degrees, which would have been a lot quicker. But there are many ways that you can solve these problems, which is really cool. So, looking at example F, I have another diameter happening. The reason why I have another diameter happening is I have this chord that goes through the center of the circle, which makes it the diameter, and angle 1 is an inscribed angle that intercepts that wonderful semicircle. And angle 2 also intercepts that diameter, which means these angles, 1 and 2, are both 90 degrees. And you will find these are really, really quick, and you can get them done and work on them. Now, you do have more complicated problems that can happen. For example, G. With G, you got to look at what you got going on. So, first thing I have is this angle right here that's 48. It intercepts this arc right here. So, to get this arc measure, I'm going to take 48 and take it times 2, and 48 times 2 is 96. Okay? With that being 96 degrees, and angle 2 also intercepts, we got two angles I can find. Angle 3 is a central angle, so it's going to be equal to the arc measure, which is 96 degrees. And then angle 2 intercepts the same arc as is 48 degrees, and they are both inscribed, so angle 2 is worth 48 degrees. So the next thing we got to play is we got to apply the triangle sum theorem and figure out what we can do. So, with that, looking at triangles and arcs, let's see what I can do. Alright, so this whole arc here is 96 degrees, which means this whole big arc see what we can do. This big arc goes this whole major arc, which can give me that big inscribed angle. Alright. Nope. Trying to think if I can make a plan. Oh, we'll see. So this big arc is going to be 360 minus 96. Let's see, 360 minus 96 is 264. So the big arc, major arc over here is 264 degrees, which means if I divide that in half, I'm going to get 132 degrees. So this angle right here is 132 degrees. Alright, so with that big angle being 132 degrees, that means this angle right here is going to be 48 plus 132 minus from 180. So plus 48 minus 180, that's not right. That's not right mathematically. Nope, because I did that wrong. This whole angle here, Oh, I know things that we can't do yet about distances and those distances being congruent. Let me double check my answer key over here. Let's see what I got going on. So maybe I can work backwards. Nope. 42, 48. How's angle 142 degrees? How is angle 142 degrees? Oh, Pomeroy, you got this. It's an isosceles triangle. So this line right here, oh my goodness, Pomeroy. This line right here and this line right here are radii, which means they are congruent. If the top angle is 96 degrees, this is x, where angle 1 is, and this is x. So I'm going to take 180 minus 96 and get 84. So that means x plus x equals 84. Divide by 2, and you get 42 degrees. I have not used an isosceles triangle and an inscribed angle in a long time. I was not paying attention to that one. So don't forget what you learned in Standard 3. It's alright. It happens. It happens. Alright, let's find angle 1. Angle 1 intercepts this arc right here because its angle is created right there. So if I have 100, that means this angle right here is 50 degrees. So angle 1 is 50 degrees. Angle 2 is an inscribed angle. That goes with this arc right over here, because its angle is formed intercepting that arc. So if I take 60 and I divide it by 2, this is 30 degrees, which makes this angle in this triangle 180 minus 80. And the reason why it's 180 minus 80 is these two added to be 80, so 180 minus 80 gives me 100 degrees, and by vertical angle theorem, angle 3 is 100 degrees, and 2 is 30 degrees. Alright, so with that, that should get you where you need to be for notes. You do have some more complicated problems on the back side, so we're going to keep going with this. I do know that this is taking longer than what I planned. I apologize. Got a little stuck on 3 problems there. Finding the measurements. We're going to skip past these inscribed angles that share points. This is a quadrilateral slash not a quadrilateral, so we're going to talk about it real quick. Linear pairs and whatnot. So angle 3 is an inscribed angle and it intercepts this arc. So angle 3 and x are related. X is the value of 110 degrees because this central angle of 110 degrees intercepts this arc. So x is 110 degrees. Now, if you look, angle 1 and angle 3 intercept the same arc because they are both hitting this beautiful arc. So if I take 110 divided by 2, I get 55 degrees. So angle 1 is 55 degrees, and so is angle 3. Now, to find angle 2, we intercept this arc over here, and if you want, this is also an isosceles triangle, because this is congruent to this, which means angle 2 is also 55 degrees, because of the base angles theorem. Or this is 80, because of linear pair theorem, and 180 minus 80 minus 55 gives you 55 degrees. Once again, triangle sum theorem is your best friend, as long as you remember what you're doing, and radii. Alright, let's go to one we haven't touched yet. Let's go talk to you about the tangent chord angle. Tangents run like inscribed angles. They are literally right on the circle, so they mimic an inscribed angle, but they're not exactly the same. So, first of all, the inscribed angle, the tangent and the chord create 2 arcs. You have a minor and a major arc. And with that, you can see that this 112 is the minor arc. And in order to find angle 1, we treat it just like what we do with a inscribed angle. We're going to take 112 divided by 2. And so this angle right here is going to be 56, I want to say, but I'm going to double check. Yep, 56 degrees. So angle 1 is 56 degrees. Now to find angle 2 and find this x value, you can do 2 things. You really got 3, but it depends on how you want to think about it. You can do major arc, minor arc, so 360 minus 112 will get you this major arc. You can do, and then work backwards to get 2. You can do triangle sum theorem, or not triangle sum theorem, excuse me, linear pair theorem. So angle 1 and angle 2 add to be 180 and work here. Or you could do a combination of the both. Meaning you could find this arc and then still do linear pair. So with that, 360 minus 112 is 248 degrees. So x is going to be 248 degrees. And if I work backwards, I should get the same answer if I take 180 minus 56. So if I divide this by 2, I get 124. And if I take 180 minus 56, I should also get 124, which I do. So angle 2 is 124 degrees. Tangent chords are fun. Once again, you have to remember that angles and arcs and central angles and everything are really important. There's an X that is missing on this diagram. See if I can find it on my answer key. I want to say X is the major arc. Yeah, X is going to be this arc over here. So I'll just explain how to find that. So that's missing. But with that, let's look at what we got. So first and foremost, we have 42 degrees here. 48 is a inscribed angle. Vertex is on the circle. So 48 times 2 gives me 96, so this is 96 degrees. Angle 1 is the same as the arc measure because it intercepts. So 96 degrees. Alright. If I take 42 plus 96, I get 138. So this whole distance here is 138 degrees for the whole major arc. Excuse me, it's not a major arc, it's a minor arc. Okay? And then if I take that away from 360, that gets me 222 over here. So the major arc's 222 degrees. Alright, last but not least, that one I'm going to leave for you to do on your own, and this one is a tangent, so I'm going to work on this tangent. So in order to find x, we have a tangent chord, so this 59 degrees equals half of the arc measure, or 2 times the little guy equals the big guy. So I'm going to do 2 times 59, 2 times the inscribed angle equals the arc measure of 2x plus 34. 2 times 59, excuse me, is 118 degrees, equals 2x plus 34. Minus 34 on both sides, you get 84 equals 2x. Divide by 2, x equals out to be 42 degrees. Alright, like I said, I'm going to leave this one to find based on 360 minus 125 minus 143. Get your arc measure and then cut in half to get angle 2. And then once again on this one here, you have 2 inscribed angles, 1 and 3, that both share 36, so we're 33. And then with that, you'll use triangle sum theorem, vertical angles, and you can find angle 2.